Okay, so this is unit number 1, number system, and you guys should not only listen to this video and follow along, but on my website there are some helpful links. Under unit 1, there are some step-by-step instructions, converting decimals to fractions, rational and irrational number practice, and a couple of Khan Academy videos. So all of those things you should check out if you're still struggling. Alright, so let's get started. Okay, so one of the topics that are going to be covered tomorrow are determining whether a number is rational or irrational. Remember that rational numbers are numbers that either terminate or repeat and can be written as a ratio or as a fraction. Numbers that are irrational are the numbers that we're unable to write as a fraction or as a ratio. So if I have the number 7.4, that terminates, so that is going to be a rational number. If I have 7.4 repeating, that is also going to equal a rational number. It repeats, therefore it is able to be put into a fraction or ratio, and it is a rational number. 5.4126, and actually I meant to have that continue on. Because I don't know the number that's going to happen next, that is going to be an irrational number. I have no idea how to guess what number is going to come after 6. There's not a pattern, so it is irrational. The square root of 86 is not a perfect square. Any number that is not a perfect square is going to be irrational. So any number I forgot my stylus at home, so it's my big bulky finger trying to write this. Any number that is not a perfect square is irrational. So the square root of 86 is not a perfect square, therefore it's irrational. However, for 64, the square root of 64, 8 times 8 is 64, so it is a rational number. Pi, and anything times pi or divided by pi, is going to be irrational. There's no pattern, no number repeats in pi, and so therefore it's irrational. 17 terminates, and therefore it is repeating, and so it is rational. I'm sorry, it's not repeating, it terminates, so it is rational. One of the topics covered on your quiz tomorrow is going to be approximating non-perfect squares. Remember, a perfect square is any number times itself, any integer times itself. So 2 times 2 is 4. So the square root of 4 is 2, therefore it's making it a perfect square. Any number between 4, 9, and 16, so the square root of 8, that is called a non-perfect square, because it's a number that is not a whole integer times itself. So to approximate those, what you're going to do, if I want to find, say, the approximate of 24, I want to find the nearest 2 perfect squares, one above and one below. So the nearest whole perfect squares, the nearest perfect squares between to 24 are going to be the square root of 25, and beneath that the square root of 16. Because 16, square root of 16 is 4, and the square root of 25 is 5. So I know the square root of 24 is going to be somewhere between those two numbers. If I have the square root of 33, again, my first step is to find the numbers closest to that are perfect squares. I know that 6 times 6 is 36, and 5 times 5 is 25. So the square root of 33 is going to be somewhere between 5 and 6. If I want to find the approximation for the square root of 33 to, say, the nearest tenth, again, we know that the nearest square roots to 33 are the square root of 36 and the square root of 25, which is 5 and 6. So we know that 33 is somewhere between, the square root of 33 is somewhere between 5 and 6. Well, the way we're going to do this is we want to count between each number. So 33 to 36 is 3, and between 33 and 25, that's 8. Obviously, 33 is much closer to 36, so we know our answer is going to be much closer to 6 than it is to 5. So we're going to approximate somewhere between 5.7, 5.8. And if you were to do that on your calculator, you would see that it is actually 5 and 7 tenths, although it's 5.744556, and it goes on forever. But if I were to estimate to just the tenths, it would be 5.7. So what we want to do is find the two nearest perfect squares and then determine which number we're closest to, the one that's right above it or right below it, and then that's how we're going to make our guess. So let's try that with a different number, say the square root of 52. And if you're doing this by yourself, it'd be a really good idea for you to be writing this one step ahead of me so that you can check your understanding. So we know that the closest square roots to 52 are going to be the square root of 49 and the square root of, sorry, I'm trying to erase some of my work, and the square root of 64. Sorry guys that this is so messy. This is the first time I've really done this, so hopefully I will get better as the year goes on. So the square root of 49, we know that is 7, and the square root of 64 is 8. And we want to figure out where between 7 and 8 the square root of 52 is. So 49 to 52, that is 3. And 52 to 64, that is 12. Obviously that's much larger. So we're going to be much closer to 7 than we are 8. This is where your best judgment's going to come in. You know it's less than halfway, and it's significantly less than halfway, so you're going to guess 7.2, maybe 7.3. And if I do that on the calculator, the square root of 52, sorry, I'm looking for my, is 7.2. So that's how we're going to find the best approximation of our square root numbers that aren't perfect squares. On your exam, you're also going to need to be able to tell us why a number is irrational or rational. A good resource for that is going to be the worksheet that you did on Friday. But again, if something can be written as a ratio, then it's rational, and a ratio is a fraction. So if the number, I can write it as 3/4. So any number that terminates or repeats is going to equal a rational number. Any number that's the square root of a non-perfect square, that's going to be irrational. We don't know what's going to be next. Okay, so you're going to need to be able, in words, explain why something is rational or irrational. Another topic that's going to be covered on the test tomorrow writing decimals as fractions. Now you're going to have two types of decimals, terminating decimals and repeating decimals. Terminating decimals are our numbers like 3.14, 7.689. They stop at a certain point. Our repeating decimals are going to be numbers like 0.69 or 73, 3 repeating. Those are our repeating numbers. You're going to make those decimals into fractions differently. So let's focus on writing our terminating decimals as fractions or mixed numbers. To put a terminating decimal as a fraction, I suggest saying it out loud or in your head. So if I am looking at this number right here, 3.14 is probably how you say it, but if you say that 3 and 14 hundredths, remember this is the hundredths place, I know that that's going to be 3 and 14 hundredths. So I'm going to write it over 100ths. For our next number right here, 689 thousandths. 689 thousandths. So I'm going to write that as 7 and 689 over 1,000. Of course, because you want full credit, you're going to simplify these as much as possible. So we're going to have 7/50ths. And then you would want to look at this number and see if you can simplify it. Always try to simplify to get full credit. So if a number terminates, it's pretty straightforward. You just need to figure out what place the last decimal is in. And if it's in the tenths place, you're going to put it over 10. If it's over the hundredths place, you're going to put it over 100. And if the last decimal is in the thousandths place, you'll put it over 1,000. That's about as large of a number that we're going to give you, or as far out as we're going to give you. Next is the concept that many of you seem to be struggling with, and that's converting our repeating decimals into fractions. So to do that, this is where you're going to be setting things equal to x and solving it that way. So let's go ahead and try one. I'm going to try it in green this time because let's change things up. So let's start with again, this is my first time using this. Hopefully I don't get you guys all seasick. So if I have 0.73 repeating, first I want to make sure that I'm paying attention as to where the repeating sign is, and this is only over the 3, so that is going to make a difference. So I want x is equal to 0.73 repeating. Now I want just this by itself, because that's what I want to get rid of. I want to get rid of any number that repeats. Well, to do that, this is in the hundredths place, so I know I'm going to have to multiply it by 100. So if I have 100x, and if I multiply by 100, that means I'm going to move the decimal place over 2. So I'm going to have 73.3 repeating. Now this number is a little bit trickier than some of our other ones because the repeating bar does not extend all the way to the decimal. It is only over the hundredths place. So if you remember when we were talking in class that for the number we subtract, it's whatever is not covered by, whatever place value is not covered by the repeating sign. And since this is the tenths place is not covered by the repeating bar, it's going to be 10x that we subtract. If the repeating bar was all the way across, the ones place would be the one that isn't covered, and so it would just be 1x. But since the tenths place, this place right here is not covered by the repeating bar, then I multiply it by tenths because that's the tenths place. So if I multiply 0.73 repeating by 10, I'm going to end up with, that would be as if I moved it only one spot. So I'm going to have 7.3 repeating. And I did not do a very good job of lining up my decimals, and when you're subtracting, that's really important, so make sure you do that, and that you pay attention as to where your decimals are. So if I am subtracting, then I'm going to have 0.3 repeating is going to cancel out. I'm going to have 0. 3 minus 7, I'm going to need to borrow. 13 minus 7 is 5, and that's a 0, so I'm going to have 65. And remember, 100 minus 10x is going to be 90x. Now I need to divide 90x on both sides. Or, I'm sorry, not 90x, just 90, because I want x by itself. So I'm going to have x is equal to 65 over 90. I know that 5 goes into each of those. 5 goes into 65 13 times, and 5 goes into 18 times. So my answer is going to be 13 over 18. Now if I had another, let's try it with our other, oops, sorry. I'm making a mess here of my work. And let's try to move back up the page, which it won't let me, so I'm going to create a new slide. Okay, so if I have 69 repeating, I'm going to set it up very similar. I have my repeating bar goes to the hundredths place, so I know I'm going to multiply by 100, 100x. And if I multiply by 100, that's the same as moving my decimal point 2 places. So I'm going to have 69 minus 69 repeating. And then unlike our other example, where the repeating symbol didn't start until the hundredths place, this one starts in the tenths place. So I don't need to multiply x by anything. I just want to make sure that I'm lining up my decimals. Those are going to subtract. We're going to be left with 69. Then 100x minus x is going to be 99x. Divide both sides by 99 because I want to know what x by itself is. And that's going to be 69 over 99. And 3 goes into both numbers. So I'm going to have 23 over 33. And that's what I'm going to be left with. So my answer is going to be 23 divided by 33. And I can always check myself by dividing that. So 23 divided by 33 is in fact 0.69 repeating. So I know that I answered that correctly. Next, covered, you are also going to need to be able to plot numbers on a number line, so be familiar with that. Remember that negatives, the larger the number, so -9 is actually smaller than -8. Okay, so keep that in mind. You have notes in your notebook about that. You'll also have a problem if you had 20 cents. What fraction of a dollar do you have? Remember that you can treat this like a decimal, and this is the same thing as 20 cents. So I have 20 over 100, which is 2/5. I've simplified. So you would just say 2/5 is the fraction. Then you also have some other fraction problems. You should be just fine with those. I really strongly suggest that you look over the helpful links and videos that I've posted on the website. Hopefully this wasn't too confusing. If you have any questions, please email me, and I will do the best to answer them via email. Okay? And hopefully these videos will get better as the year goes on. Good luck. I know you guys can all do fabulously. I'm proud of all of you. Just remember to study and practice. All right, we'll see you tomorrow.